Picture this, a world where crystal clear water flows freely, even in the driest regions, where every drop is precious, protected, and purified. This isn't a mirage, it's the revolutionary future of water storage, powered by the tiniest marvels of science. Welcome to the Fields of Innovation YouTube channel, where smart farming starts here. Discover the future of agriculture as we dive into the nano-sized solutions making big waves in water conservation. Today, we're exploring a critical issue affecting millions worldwide. The global water crisis. Even in developed nations like the United States, Australia, and parts of Europe, water scarcity is becoming an alarming reality. California's persistent droughts, Australia's parched outback, and Spain's dwindling reservoirs all paint a stark picture. Climate change has thrown traditional rainfall patterns into chaos, making droughts more severe and unpredictable. But why can't we simply store more water? The answer lies in the limitations of conventional storage methods. Dams, reservoirs, and tanks, once hailed as marvels of engineering, now face significant challenges. High evaporation rates steal precious water from open reservoirs. Contamination risks threaten the safety of stored supplies. And leaks, both small and large, drain away resources we can't afford to lose. These issues don't just reduce water availability, they compromise quality and highlight an urgent need for innovation. Enter the world of nanomaterials, the game-changing technology that's revolutionizing water storage. But what exactly are nanomaterials? Simply put, they're materials engineered at the nanometer scale, ranging from 1 to 100 nanometers. To put that in perspective, we're talking about particles roughly 100,000 times smaller than the width of a human hair. It's at this minuscule scale that materials begin to exhibit extraordinary properties. The power of nanomaterials lies in their unique characteristics. First, their incredibly high surface area allows for maximum interaction with water molecules. This translates to more efficient filtration and purification. Second, nanomaterials boast enhanced reactivity, enabling them to neutralize pollutants and harmful bacteria with unprecedented effectiveness. Lastly, their durability means that nanotech-enhanced coatings and composites far outlast conventional materials, leading to longer-lasting, more reliable water storage solutions. So how are these tiny marvels transforming water storage systems? Let's explore three key applications. First, we have nanocoatings. These ultra-thin layers can be applied to the surfaces of storage tanks and reservoirs, creating a powerful barrier against evaporation. They also inhibit the growth of algae and bacteria, keeping stored water fresher for longer. As an added bonus, these coatings resist corrosion, extending the lifespan of storage infrastructure. Next, we have nanofilters and membranes. These advanced materials feature precisely engineered pores that can trap microbes, heavy metals, and other contaminants. The result, a continuous purification process that keeps stored water clean and safe, even over extended periods. This technology is particularly promising for regions where water quality is a major concern. Lastly, smart nanocomposites are revolutionizing the very materials we use to build water storage systems. These advanced composites combine the strength of traditional materials with the unique properties of nanoparticles. The result? Tanks and reservoirs that are stronger, lighter, and incredibly resistant to leaks. This means more reliable storage with less maintenance, a win-win for water management. The benefits of these nano-enhanced water systems are truly game-changing. Let's break them down. First and foremost, we're talking about unprecedented efficiency. By reducing leakage and lowering evaporation rates, nano-enhanced systems ensure that more of the water we store remains usable. This is crucial in water-stressed regions where every drop counts. Durability is another major advantage. Nano-enhanced storage systems boast significantly longer lifespans compared to their traditional counterparts. This translates to lower replacement and maintenance costs over time, making water storage more economically sustainable for communities and governments alike. Perhaps most importantly, these innovations bring major improvements in health and safety. Water stored in nano-enhanced systems stays cleaner and safer for drinking, dramatically reducing the risk of waterborne disease outbreaks. This is particularly crucial in developing regions where access to clean water can be a matter of life and death. But these aren't just theoretical benefits. Nano-enhanced water storage is already making a real-world impact. In the United States, California's agricultural sector is embracing nanomembrane technology to preserve precious irrigation water. Australia, no stranger to drought, is conducting trials with nano-coated reservoirs in its most arid regions. Over in Europe, countries like Germany and the Netherlands are experimenting with nanofiltration systems for municipal water storage. It's not just large-scale projects seeing success. Villages in water-scarce areas are benefiting from small nano-enhanced tanks. This proves that the technology is scalable and adaptable to rural needs, offering hope for communities often left behind by large infrastructure projects. However, as with any emerging technology, nano-enhanced water storage faces its share of challenges and ethical concerns. Cost and accessibility remain significant hurdles. Nanomaterials are still relatively expensive to produce, potentially putting this technology out of reach for developing countries that need it most. This raises important questions about equitable access to water-saving innovations. Environmental risks also need careful consideration. While nanomaterials offer tremendous benefits, the accidental release of nanoparticles into soil or water systems could have unintended consequences for ecosystems. Rigorous testing and containment protocols are essential to ensure these materials remain where they belong. In our water storage systems, not in the wider environment, regulatory frameworks present another challenge. Many countries lack clear guidelines and safety standards for the use of nanomaterials in water storage. Developing comprehensive regulations that protect public health while encouraging innovation will be crucial for widespread adoption. Despite these challenges, the future of nano-enhanced water storage looks incredibly bright. We're seeing exciting developments on the horizon that could take this technology to new heights. Imagine solar-powered nanofiltration systems providing sustainable off-grid water storage in remote areas. This integration with renewable energy could be a game-changer for water security in developing regions. Nanomaterials are also poised to play a crucial role in the circular economy. By making it easier to reuse and recycle water, these technologies could help close the loop in resource use, creating more sustainable water management practices across industries. And the innovations keep coming. In the next decade, we can expect to see breakthroughs like self-cleaning tanks that use nanoparticles to automatically purify stored water. AI-powered smart systems could optimize water use and quality in real time. Perhaps most excitingly, researchers are working on more affordable, scalable nano-solutions that could bring this technology to communities worldwide. As we wrap up our exploration of nano-enhanced water storage, let's recap the key points. Water scarcity is a growing global challenge, and traditional storage systems simply can't keep up. Nanotechnology offers a powerful solution, bringing unprecedented efficiency, safety, and sustainability to water storage. From nanocoatings that prevent evaporation to smart filters that purify continuously, these tiny innovations are making a big impact. But the future of water security isn't just in the hands of scientists and engineers. It's in yours too. Stay informed about these emerging technologies, support research and development in sustainable water solutions. And most importantly, be an advocate for responsible innovation that addresses our water challenges while protecting our environment. We want to hear from you. Share your thoughts in the comments below. What potential do you see in nano-enhanced water storage? Do you have concerns about the technology? Your insights help drive the conversation forward. And don't forget to subscribe to the Fields of Innovation channel for more cutting-edge content on green technology and agricultural innovation. Together, we can cultivate a future where clean, abundant water is a reality for all. Until next time, keep innovating.